Welcome back everyone. Let's now have a look at an example of a present value calculation with multiple cash flows. So congratulations, you are the lucky winner of a $1 million online lottery. What a great problem to have, right? So as per the fine print, you can take your prize money as either A series of 4 annual payments as shown in the table below. So if you choose option A, you receive $100,000 up front, $200,000 1 year from now, $300,000 in year 2, and $400,000 in year 3 to add up to a total of $1 million. Or you can choose option B, one lump sum payment of $400,000. So if you're ever fortunate enough to actually encounter this problem and you win a large jackpot from a lottery, you'll be presented with two very similar options. So it's quite typical that the jackpot is actually spread over multiple years, where you receive part of your jackpot like up front, and then you'll receive like a continuing amount year on year on. So for very large jackpots, it's generally spread over 30 years. I think for some of them, they also offer you the option of taking like a lump sum payment right up front, but generally speaking, they essentially discount the jackpot amount like quite significantly. So often it's actually not worthwhile to take the money up front. So if your required return is 10%, which option would you choose? Option A or option B? So in this particular question, what we're trying to get you to do is to essentially calculate the present value of all of these cash flows here and then essentially add them all together. So remember, the time value of money concept basically states that money in different years is not comparable. So what we'll need to do is actually discount year 3, year 2, year 1's cash flow back to the present time, year 0, and then add them all together to get the present value of this option here. And then what we need to do then is essentially compare that dollar amount with this $400,000 and essentially see which one is larger. And the larger option will be the better one. So it might help to start just with a timeline. So if I draw a timeline for option 1 or option A, in year 0, you get $100,000. Year 1, you get $200,000. Year 2, you get $300,000. And in year 3, I believe you get $400,000. So we can't essentially compare this option with option B by simply adding these values together. So we can't just go 100, 200, 300, 400 and say, oh, that's the present value of option A. What we need to do is discount these values back to the present time. So for the $200,000 cash flow, because you received it in year 1, we'll have to discount it back 1 year using the present value formula. For the $300,000 amount received in year 2, you need to discount it back 2 years. And for the $400,000 amount, you need to discount it back 3 years. Okay, so remember what our present value formula is. The present value is equal to the future value amount, so the lump sum amount, divided by 1 plus r taken to the power of t, where t is the number of periods you need to discount it back to bring it back to the present time, so year 0 in this case. So r is given in the question up here as 10%. Okay, so 0.10 as a decimal. So the present value of, say, the cash flow that you receive in year 0 is $100,000. Okay, so because this cash flow is received right now in year 0, it's already in the present time, and you actually don't need to discount it back. So for those of you that are curious, if you do discount it back, so you divide it by 1 plus r to the power of t, you find that t actually the value of t is 0 because you're already in the present time, and this whole term actually goes to 1. So the present value of our very first cash flow is quite easy. It's just $100,000. The present value of our cash flow received in year 1 is equal to $200,000. So that's the future value amount that we received in year 1, divided by 1 plus the interest rate of 0.10, bracket, taken to the power of 1. And it's taken to the power of 1 because you need to discount it back 1 year. Okay, so if you evaluate this term in your calculator, you should get approximately $181,818.18. Okay, And essentially what we need to do now is repeat this process for the cash flow received in year 2 and the cash flow received in year 3. So in year 2, we receive $300,000. Okay, our discount rate is exactly the same, so it's still 10%. The only thing that's changed is now we need to discount it back 2 periods. So if we go back to our timeline, you see we received the $300,000 in year 2, and to discount it back to the present time, so year 0, we need to bring it back 1, 2 years. Okay, and if you evaluate this term here, you get $247,933.88. Let's now repeat it for the present value, the cash flow received in year 3. So we received $400,000 in year 3. So divide that by 1 plus 0.10, taken to the power of 3 because we received it in year 3, which means we need to discount it back 3 years. And if you evaluate this term here, you get $300,525.92. Okay, so now that we've calculated the present value of each of these cash flows, so we've calculated the present value of the cash flow received in year 1, 2, and 3, all of these cash flows are now presented in terms of time 0. So what that essentially means is that we can add all of these values together and get the present value of option A. Okay, so another way to kind of think about it is instead of receiving, say, all of these cash flows, so 100, 200, 300, 400 spread over 3 years, what's the equivalent lump sum of those future payments right now? Okay, so the present value of option A is just the present value of the cash flow received in year 0, the present value of the cash flow received in year 1, the present value of the cash flow received in year 2, and the present value of the cash flow received in year 3. Okay, so present value of our first cash flow is $100,000. Present value of the cash flow in year 1 is $181,818.18. Present value of option 2 is of cash flow 2, I should say, is $247,933.88. And finally, the present value of the cash flow received in year 3 is $300,525.92. And if you add all of these together and put it into your calculator, you should receive, or you should get, approximately $830,277.98. Okay, so what does this essentially mean? So as we discussed before, this is essentially the equivalent lump sum payment the equivalent lump sum payment of the series of cash flows series of cash flows in option A. Okay, so what that means is if instead of waiting 3 years to receive 100, 200, 300, and 400,000, the equivalent present value amount, if your required rate of return was 10%, is $830,277.98. So comparing this to option B, right? So option B, oops, we'll go back to white. So option B will give you $400,000 upfront. So the present value of option A is $830,277.98, and that is clearly better than taking option B. Okay, so the short answer of this question is, unless you really need the money right now, it's far better to take option A. As the present value of option A is significantly larger than taking option B, so it's much better to take option A, as the present value of option A is significantly larger than that of option B, where its present value is only $400,000. Okay, and that's it, guys.